But for now, I'm going to run you through this first example on how to design a segmental pavement for general usage. Right, so this example is actually a real life example that we got at CMAA, where somebody wanted to have us design or get them an initial design for a hard stand for a mine in Western Australia. So in the example, again, a hard stand for a mine in Western Australia, it was specified that the base course is to be designed under an 80 millimeter thick paver, as well as 20 millimeters of bedding material under the paver. It was also told that the CBR will be 5% and that we're expecting about 150 repetitions of a triple road train, right? So firstly, let's open up DesignPave. When we want to start a design project, first we click Design and we click Road. James will go through how to design industrial pavements later on, but for this section, we're going to go through road design. When you design your pavement through DesignPave, you have two options for traffic estimation. You have ESA, equivalent standard axle, and you also have AADT, annual average daily traffic. AADT is more accurate, and depending on whether you have the additional data, you can choose to use AADT for a more accurate traffic estimation. In addition to that, you also have the option to input your own traffic spectrum from a WIM survey, if you have that from an Excel file or a CSV. But for this example, we weren't given that much data, so we're going to use ESA, right? So from this example, we weren't directly given the ESA, we were given the repetitions. So our first step is to calculate the equivalent standard axle, right? And from Unit 2 or Unit 1 of the webinar series, we learned how to calculate the ESA. And it's basically your load magnitude on your load for your standard axle, which you get from Austroads, times the number of repetitions. And my computer's a little bit slow, so bear with me. So for this example, we were told that we were expecting 150,000 repetitions of a triple road train. And to calculate the ESA, basically we find out what axle groups we have for our particular vehicle type, which we see on the right. And from that, we calculate the ESA for each individual axle group. So for this triple road train, we have SAST, TADT, which is 4 wheels in 2 axles. And we also have TRDT, which is 3 axles with 4 wheels on each axle. All right. And summing all of these ESAs up, we get the total ESA of about 985,000, right? Once we've gotten the ESA, we can then go back to DesignPave and input our data, right? So let me go back to the example. So we got 985,000 ESA. You can choose to round up to 1 million ESA, which is what I'm going to do in this example for simplicity. And again, we also find that our CBR is about 5%. We add that in. And we have to remember to calculate the equivalent subgrade modulus, which is just 10 times the CBR. Here you have different options for the different pavement types that you can use. You can use a base course with subgrade, the simplest one, or if you find that you want to use a stronger pavement, or you want to minimize your thicknesses under your pavers, you may choose to use a base course with a subbase, or alternatively, a base course with a stabilized subbase. For this example, we're going to keep it simple and use a base course with a subgrade. In this next slide, this is where we input some of our values. Again, in the example, we were given an 80 millimeter paver, which is probably your most common paver that you'd get, and also 20 millimeters thick bedding material, which is a standard thickness. I'll give you a little tip here for DesignPave. You can actually use your advanced design option if you go into File and press Advanced Design. And what you can do is you can change the modulus of each layer in your pavement, right? So if you have a base course with a higher modulus, you might change it to 3,500, for example. 350 is the default modulus for your crushed rock base, according to Osroads. So let me change that back. And next, to find out your base course thickness, it's fairly simple. You just click Redesign /Design, and you get an output of 295 millimeters for your base course thickness. If you're interested in how different ESAs might affect your thickness, you can also press Design Chart, which will give you a chart of the thicknesses versus the ESAs you have. So obviously, the less ESAs you have, the less thick your base course needs to be. All right. Once we've designed our base course thickness, we are taken to a cost analysis section, which you can fiddle around with by yourself. It's just an added feature. And finally, you can generate a PDF report, which shows not only the outputs that you've received, but also a lot of the design methodology behind the software as well, how we got these inputs and how we calculated them. So that brings us to the end of our first example.